All right, so I'm going to talk to you about one of your problems from the related rates section of your notes, a highway chase. I want you to find it, I want you to read it, and I want you to read it for the first time through, and then I'm going to read it with you for understanding. So the first time through, I just want you to get the basic picture, pause me, and then turn me back once you've read it once. All right, now that you've read it once, let's read it for understanding. So you've got a police cruiser. They're approaching a right-angled intersection from the north. That means they're from the north, so they're going south. Do not mock my terrible drawing. We've got this police car, that's the sirens, trust me. And they're going this way. They're going south, like the arrow shows. So it's chasing a speeding car that has turned the corner and is now moving straight east. Okay, straight east. That way is east. All right. So, pictures are not to scale. Now, here's my getaway car. They are bandits. When the cruiser is 0.6 miles north of the intersection, so basically this distance right here is 0.6. So let's fill that information in. Now keep in mind that's variable. So this needs a variable. We don't know how much distance, we know what it is at this moment, but that is changing, so we need a variable distance. And also this guy, it said was 0.8, but again, that's a moment in time. That is not the constant distance that car is moving. So y is changing. Now, it is 0.8, all right, to the east. We got all that information. The police determine with radar that the distance between them and the car is increasing. Okay, wait a minute. The distance between them and the car is this. We're going to call that Z because I got to do something. So the distance between them and the car is increasing at 20 miles per hour. That is a rate. That's a D something, D something. The distance between those two cars and where a police car would shoot radar at another car would be a straight line distance between the two cars. That is a DZDT. So now that means that that is equal to 20 mph. It is increasing, so it's positive. All right, if the cruiser is moving 60 miles an hour, okay, that is a rate, 60 miles per hour. That's a dx dt is 60 mph. All right, what is the speed of the other car? Okay, because we know the speed of the police car must be the other car. So we're asking dy dz. That the amount this is changing. That'd be the speed of that getaway car. All right, what does that equal? And remember, we have two givens. We have that x equals 0.6 and y equals 0.8. All right, we got a right triangle. Clearly right. North, south, and east, west are at perpendicular angles. So x squared plus y squared equals z squared. I want you to pause me again. I want you to take the derivative using implicit differentiation. You're going to have dx dt's and dy dt's and all that stuff. I did just notice that I hope I said it wrong, or said it right rather, not wrong, but I have a dz and it should be dy dt. Am I crazy? So go ahead and pause me and do that. So derivatives. You're going to get dx dt. I am really not wanting to write my t's, but a 2x dx dt plus 2y dy dt equals 2z dt dz dt. Now it's a matter of plug and chug. However, we have one missing piece of information, and that's z right here. How do we find it? A squared plus b squared equals c squared. We already know that at this moment of time, now that we have our information, we can substitute in to our problem and get negative, crazy lady, at 0.6 squared plus 0.8 squared equals z squared. Use the given information for this moment in time to find out how much the distance between them is at this moment in time. Now, I'm seeing a 6, 8, 10 triangle here. So if you see that right away and you know that z equals 1, go for it. Otherwise, you're going to have 0.36 plus 0.64 equals z squared. And I think you'll quickly see that z has to be 1. All right, so now let's go ahead and substitute our information in. We've got 2 times 0.6 dx dt is 60 miles an hour. Now, we have one addition to that. Look at what x is doing during that time. Is x itself, this distance here, changing in a positive manner or a negative manner? Is it increasing or decreasing? I think it's decreasing. So we need to put that negative there. That's a negative 60, and it's going to impact your problem if you don't have that negative here today in this particular problem. So we have 2. Now y. Let's think about the same thing with y. Is this distance increasing or decreasing? As this car comes over here, isn't y getting bigger? So that is an increasing rate of change. So that one's positive. That's the value we're looking for, though. So we're hoping for a positive answer when we do our work. All right. And we have 2 times 1 times dz dt is positive 20. We already talked about that. It's clearly getting, it said right in the problem that that was increasing. This one, the dx dt, we had to think about. All right, I want you to plug and chug and see if you can get that answer. All right, now that you've gotten a chance to try that, you can see my work, but I did get dy dt equals 57.5 miles per hour. And there you have it.